Okay, let's prove the first rule of multiplication, that a times 0 is 0 times a is equal to 0. Okay, let's prove that. So let's choose an a and r, because this has to be true for all ring elements. A in R, and R denotes our ring, not necessarily the real numbers. Then what do we need to show here, and what do we even have to work with? Well, we do have to work with that we have an additive identity. And if we are taking our additive identity and adding it to anything, it's just that anything. So if we take 0 and we add it to a times 0, it's a times 0. So that is definitely true because we are in a group. Our ring is a group, and a times 0 is an element in our group. And a plus a times 0 is equal to a times 0 because 0 is the identity, the additive identity. Okay, but now because we are in a ring, we can use our distributive property. But what are we going to use it on? Well, 0 is 0 plus 0. And so we can say a times 0 is equal to a times 0 plus 0. And that now allows us to use the distributive property. So we have this is equal to a times 0 plus a times 0. And now we've gotten to a point where we can get rid of one of those a times 0 and show that a times 0 is equal to 0. So let's just look at where we started. 0 times a times 0 is where we started, and we have a chain of equalities. So at the end we have a times 0 plus a times 0. And now we have right cancellation, again, because we are in an additive group, we have right cancellation, and so we get that 0 is equal to a times 0. So that is how we are getting that 0 is equal to a times 0, and a very similar argument would show us that 0 times a is also equal to 0. And then putting those together gives us our rule of multiplication number 1. Before we finish this discussion, let's again revisit what the reasons for our chain of equalities were here. So the first one was just the definition of 0, okay, because 0 plus anything is at anything. And then, which also is the reason for our second equality, because 0 plus 0 is 0. And then the third equality right here, that was distributivity. So that's where we actually needed our ring property right here. And that then allowed us to use right cancellation, which we have because, again, we are in an additive ring.